Alright guys, so today we're going to talk about similarity in right triangles. So we're going to piggyback on our proportions that we have dealt with in the past dealing with similarity. The first thing that we're going to do is we're going to examine one right triangle that has an altitude. And with that altitude, what it's doing is it's creating three triangles that are similar to one another. Okay, so you need to know the content of this theorem. The altitude to the hypotenuse of a right triangle, the altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other and to the original triangle. The original triangle is the big guy. All right, so what we're going to do first is we're just going to examine the similarity statement, and we'll practice a little bit of this. So here's your triangle ABC, and I'll draw it and label it with the drawing. Okay, so A, B, C is our original guy. Now, what I'm going to do is I'm going to take A, C, D, and you know that angle A is congruent to angle A. So all I'm going to do is redraw it to orient it so I can see it. Your right angle is going to be your guide. Here's your D right here with your right angle, and then here's your C. Okay, so just like ABC, he's going to be similar to ADC. Now let's go ahead and let's look at this little guy right here. Again, I'm going to orient it. I'm going to go ahead and get my right angle. Angle D is going to be your right angle. B is going to be the same V as you have in this triangle right here. Okay, so here's your angle B right here. And then you have your angle C. So I basically just redo it so it can make sense to me. Therefore, angle ABC is similar to angle ACD, which is similar to triangle ABD. All right, so if you guys take it and redraw it, you can really see how those three triangles come together. Use your right angle as your guide. So this is what we're going to do. We're just going to practice writing a similarity statement and getting used to these triangles. So I'm going to do the same thing I just did a second ago, guys. I have triangle, my big guy, SRT, and he's going to be similar. I'm going to go ahead and just orient my other guys the same way, just to take the guesswork out of it. And we'll go ahead and we'll do this next in line. It doesn't matter the order you do it in, whatever works for you guys. P in this case is going to be my right angle. T is the same as this letter T right here, and this is going to leave S at the top. So I took care of this guy. Now I need to take care of this guy right here. All right, well, again, I'm going back to my original. R is the same R. What is my right angle here? He's going to be P, and then this S is going to coincide with T in my other two triangles. So my similarity statement is going to be that triangle RST, and again, it doesn't really matter the order, as long as your letters match up. Is similar to triangle SPT, is similar to triangle RPS. Okay, RST, SPT, RPS. So again, as you guys can see, redrawing it really helps keep your head straight with this. We're going to take this concept, guys, and get a little bit deeper. So this is going to lead us to our definition of geometric mean. All right, now the means of their proportion are the same number, okay? So X in this case is what's called your mean. That number is going to be the geometric mean of the extremes. So A and B in this case are going to be your extremes. Okay, just a little bit of terminology, all right? So stay with me. The geometric mean of two positive numbers is the positive square root of their product, okay? The geometric mean of two numbers, all right? So this is basically your formula, okay? X squared equals AB. It's just coming from your cross products. The geometric mean is the positive square root, okay? So your geometric mean, your X, is going to be the square root of baby. This is essentially your formula that you guys are going to use, okay, when I say find the geometric mean. But where it comes from is setting up these proportions. And as you guys see in a second, it's going to all tie together when we're solving for our triangles and writing our similarity statements. We're solving for the sides. Okay? So I want to go through and talk to you guys about this a little bit in more detail. We're actually going to go for, where are we here? Let's go through here and let's find a couple geometric means and we'll see how this applies. Okay, so it wants us to find the geometric mean. This is basically just a vocab term, guys. Okay, to find your geometric mean, you're going to use your formula. X squared equals 4 times 9. X squared equals A times B. X squared equals 36. So X is going to be 6. Your geometric mean of this is 6. Same thing here. X squared equals A times B, so X squared equals 6 times 15. X squared equals 90. Use simplified radical form, please. So you're going to get X equals root 90. Break that 9 out. 3 root 10 is going to be your final answer for that. Okay? So like I said, guys, what we're going to do is we're going to hang out for a second and see how this applies. I want you guys to take a second and write down my top drawing. And basically, as you guys notice, this is your big triangle. Here's your altitude. So because of the fact that it's connecting to the hypotenuse, it's going to make 2 other similar triangles. All right? And based on the relationship that I just went through and showed you guys, we're going to use our proportions in order to solve for these guys and find out what these other side lengths are going to be. We're basically gearing up to solve for X and Y and H and B. Okay? So the first thing that we're going to do is we're going to use our geometric means. I'm going to set up a proportion. I want you guys to follow me on this. All right? So I am going to do Y is to H. I'm looking at this triangle. So my base is to my altitude. And then comparing it to this triangle. My base is to my altitude as my base, or I should say my base is to my altitude, okay? Now there's going to be a shortcut that I'm going to show y'all, so stay with me. If I go through and I do my cross products, look you guys, your H is going to end up being the geometric mean of the product of these. So H squared equals the product of those based on the proportion that we set up, okay? So let's continue on that path. Now I'm going to go through, and I only labeled a couple to kind of help keep our heads straight. What I'm going to do is I'm going to compare this triangle. I'll go ahead and give myself a right angle here. Compare this triangle to my large guy, okay? So, looking at our large guy right here, my hypotenuse is to my shorter leg. My hypotenuse of my big guy is to my shorter leg. And then we're going to zero in on this yellow guy. As my hypotenuse of my shorter guy, or smaller guy, is to my shorter leg of my smaller guy, okay? Hypotenuse to shorter, hypotenuse to shorter. Do your cross products, you're basically solving for A to get that value. Your geometric mean is going to be A equals the square root of XC, okay? So, A squared, you guys can zero in on this. A squared equals X times C, all right? H squared equals X times Y. A squared equals X adjacent times C. And let's do this last one here. Now, we're going to explore our big guy with our middle guy, okay? So our big guy, if we look at what's labeled, C, our hypotenuse of our big guy, is to be the longer side, as our hypotenuse of our medium guy, B, is to y, the longer leg. All right, and again, that goes straight from our similarity. B squared equals C times y. You can take the square root of both sides, and you basically are taking the mean. Okay, this is what I would like for y'all to focus on. All right, B squared equals y times c. So let's put this together. All right, you guys, that's where it comes from. Just like I told y'all, h squared equals x times y. That is when you're comparing these two triangles right here. So it'll basically tell you find h. H squared equals x times y. Then we're going to get into our adjacent guys. If you're comparing this triangle to your big guy, a squared equals x times x plus y, or c. B squared equals y, your adjacent leg of your smaller guy, times the large length. Okay, that's a lot to wrap your mind around, but that's your pattern there. Okay, the explanation I just gave you is where it comes from. So you guys can memorize these, or you can set up your proportions if you prefer to do that and find the mean. Alright, so here we're going to do this, guys. Now, let me tell you this. In your homework, you may have to use your Pythagorean theorem to find some of these values to get you going. Okay? So let's go ahead and let's explore this, and then I'll explain that in more detail. It wants us to find these side lengths. We have x, we have z, we have y. Alright, so let's go ahead and let's start with this. Sometimes you may not have enough pieces of the puzzle. Like I said, you might have to use your Pythagorean theorem in order to get a piece of the puzzle to keep going. Okay? So just like I told y'all, x squared equals 2 times 10. Z squared equals adjacent times big. Y squared equals adjacent times big. Okay, so let's start with x. Luckily, this problem gave us everything we need. X squared is going to equal 2 times 10. So x in this case is going to be root 20. And then, of course, simplified radical form, guys, 2 root 5. All right. Y squared equals adjacent times the big guy, 12. I got 12 by 10 plus 2. Y equals root 120. Yes, which is going to be break the 4 out of jail, and you get to root 30. Okay, and then your z squared equals adjacent times big guy. So adjacent times big guy. Z equals root 24, break 4 out of jail, and you get 2 root 6. Okay, so this one fell right into our laps. This is going to be your homework that you're going to work on. What I'm going to tell you guys to do is go ahead and work on number 16, and then once you guys get into the section where you're solving, I want you to do 25 first. Then I want you to go back and do 24 and 26. With 24 and 26, you're going to need to use your Pythagorean theorem first in order to use the formulas I just gave you. Okay, that's my hint, guys. All right?